To see how the mask helps you identify the network and know parts of the address, convert the address and mask both to binary numbers. Once you have the address and the mask represented in binary, then identifying the network and the host ID is easier. Any address bits which have corresponding mask bits set to 1 represent the network ID, and any address bits that has corresponding mask bits to 0 set to 0 represent the node or the host ID. In this example that we have here, I didn't change or convert the address to binary numbers because, as you can see, 255, 255, 255 all is set to 1. So here will be our network ID, and this little guy here will be our host ID, setting that subnet mask is actually 254 to 0. That is in the case when the subnet mask is class C. Let's understand what is subnetting. Subnetting allows you to create multiple logical networks that exist within a single class A, B, or C network. If you do not subnet, you're only able to use one network from your class, which is pretty much unrealistic. Each data link on a network must have a unique network ID, with every node on that link being a member of the same network. If you break a major network, class A, B, or C, into a smaller subnetwork, it allows you to create a network of interconnecting subnetworks. Each data link on this network would then have a unique network subnetwork ID. Any device or gateway connecting to n network subnetworks has n distinct IP addresses, one for each network subnetwork that is interconnecting. In order to subnet a network, you must extend the natural mask using some of the bits from the host ID portion of the address to create a subnetwork ID. For example, giving a class C network of 204.17.50, which have a natural mask of 255, 255, 255.0, you can create subnet in the following way. For example, given a class C network of 192, 168, 101, which have a natural mask of 255, 255, 255.0, you can create subnets by extending the mask. For example, if we extend the mask to 255, 255, 255, 224 instead of 0, that means that you have taken 3 bits from the original host portion of the address and used them to make subnets. With these 3 bits, it is possible to create 8 subnets. That means you are going to use 2 elevated to the numbers that you took to create subnets, in this case was 3, and give you a total of 8. The total of 8 means the subnets. With the remaining 5 host ID bits, each subnet can have up to 32 host addresses, of which can actually 30 can be assigned to devices, since host IDs of all zeros and all ones are not allowed. Remember, these are special addresses that are multicast and unicast. When subnetting, you have to keep in mind the certain range within the 3 classes that we have been talking about that are not usable because they fall into the ranges defined and reserved for special uses. You can actually find these addresses in the table 3.7 that you can find in page 91 of the book. You also can find these in the request for comment 330. You can look this online and it's gonna show up right away for you. The current method for IP address allocation is the classless interdomain routing, or CIDR. The CIDR system deals with the limitation of classful addressing by allowing the allocation of IP addresses based on need, not general classification. CIDR uses variable length subnet masks to provide individualized network addressing. Note that CIDR provides a different weight of notation and address. CIDR creates a hierarchical addressing structure by breaking the network address space into CIDR blocks, which are identified by leading bit string similar to the class for addressing. However, the length of the bit string identifying a CIDR block is specified as a part of the block name using the CIDR notation. CIDR notation describes a network by specifying the base address and the number of bits used for the network portion. Also, CIDR notation can be viewed as representing a bit mask dividing the routing network information and a block of local addresses. So pretty much what you need to do to identify the CIDR notation is take the number of bits that you're using for identifying the network ID of your subnet mask, count them, and that will be your CIDR notation pretty much. So in this subnet mask, we have 255, 255, 255, 128, and when we change it to binary, we have a number of 25 ones that identify the network ID, and that will be your CIDR notation. This part I'm going to skip it because we already talked about how identifying the number of subnet that you can have when you take some bits to use them from the host portion of your subnet mask. In the ranges of IP addresses, we have public and private address. Public addresses are issued IP addresses that are available from the internet. These addresses are centrally registered and maintained through the Internet Corporation for Assigned Names and Numbers, ISPs, and domain registration organizations. Along with the distribution of public IP addresses, these organizations maintain domain name registration and top-level domain name servers. Any resources on the network that needs to be accessible from the internet must have a public IP address. On the other hand, a private IP address is not available or writable on the internet. They are for use by administrators deploying internal network. Private IP addresses allow administrators to create workable internet works for their internal networks while needing only a small number of public addresses. This is why we use the network address translation that we actually gonna talk about it later.